Hello, how are you? 2 more minutes, okay? Okay, we have to get started, okay? Okay, so this week, we already finished our review for the multiple choice, okay? So we are focused on the FRQ review, okay? FRQ review. So first thing is that we have a few slices left and we will go over the different algorithms. So first thing is that you need to remember a few algorithms. And these different algorithms, you must remember them by heart. So in the exam, you'll be able to design them. Okay, so first one you must remember is the swap algorithm. Okay, there are many algorithms basically developed by swap. So you must remember this swapping. Okay, so this one let me repeat one more time. For swapping of two data. Okay. So you have two data. You have integer a equals 3. You have integer b equals 4. Okay. So we kind of print them first. Okay. So we print a and b. Okay. After that, we would like to swap them. So we set a variable temp, okay, and temp equals, you have A, you back up A to temp. So temp becomes 3, okay? And then you copy B's value to A original 3, B's value is 4. So you copy B to A and then copy temp to B. Okay, so this is the first step. Second step is here. Third step, you copy the temp to B. Okay, so these are 3-step rotational swap. So A's value assigning to temp, okay, and then B's value assigned to A, okay. I'm sorry, this A's value assigning to temp, okay, and B's value assigning to A, okay, and then temp's value assigning to B, okay. So this one is the first one, swap base. Okay, this is swapping. Okay, you do swapping. Okay, that's the first one called swapping. Second one is called do shifting. Okay, shifting. So shifting algorithm is similar to swap. Okay, similar swap. So let's do shifting. So let's have a array. Okay, so let's assume that we have array. Okay, A equals 1, 2, 3, 4, 5. Okay, and we would like to basically shift that. Okay, so shift that. So given you this array A, you would like to shift that. Okay. So we will create. We will actually do shift. So basically, you pick up your temp value. You have 1, 2, 3, 4, 5. You pick up your 1 to temp value, and you copy 2 to 1, 3 to 2, 4 to 3, 5 to 4, and then eventually copy 10 to 5. Okay. So this one, you have the 10 value, it is equals A 0. Okay, and for integer I equals 0, I less than data length. Okay, I increase. Okay. You kind of copy one by one to its previous value. So here it's starting from 1. So your A's I minus 1 will be equals A's I's value. At the very end, your A's I'm sorry, A the length, the last one, minus 1 should be equals A's, should be equals 10. Okay, so this one will do left shifting. Okay, and then at the end, you need to return your A array. Okay. So we print out the original array first. Okay. And then we shift left of the A, okay. And then we actually print out one more time. Okay, this one's shifting to the left. Okay, this one to shift to the left. Okay. Again, it's similar to the swap algorithm. Okay. This one shifting to the left. Okay, shift to the left. Now we want to shift to the right. So shift to the right is actually similar. Okay. You pick up your last data first. Okay. You pick up your last data first. Okay. So basically, right now, let's have this one shift right 1, 2, 3. 4, 5, shift to right, you take a 5 to 10 value, and you copy one by one, okay? And then eventually copy 10 back to the first value, okay? So something like that. So that's actually 3, okay? So first you pick up your last value. And each different algorithm, you must remember that, okay? And then you do a backwards reversal, okay? And then you copy to the left, copy to the right, okay? Copy to the right. Okay, and eventually your A length, okay, minus this value, okay, I'm sorry, A0, okay. Your A0 will be assigned by the 10 value. Okay. And eventually you need to return A as well. So this one's shift right. Okay, so we copy this one for shift right. Okay, these are different algorithms. So when you practice, you need to do the same thing that I'm doing. Okay, trying to memorize each of the algorithm by heart. Okay, so this one shift to the left and then shift back to the right. So you go back to the original condition. Okay, so this one we shift left, shift right. Next one, we may have a matrix. Okay, we may have a matrix. So this one do area shift. Okay, area shift. So here you will do area shift to the left. Okay, so giving you a matrix and do area shift. So first thing that we must have a matrix. Okay, so this one is actually have this matrix n. Okay, equals 3 rows. So 1, 2, 3. Okay, and then 4, 5, and 6. Okay, and then 7, 8, 9. Okay, let's assume that this is the array matrix we have, and we should have a public, okay, static, okay, void print matrix. So we would like to have a function that can print out the matrix, okay. So these different functions, you must memorize them, okay? 1 dimension, 2 dimension basic algorithm, you must memorize. So this one, you traverse every row, every column, okay? And the change of the row, you actually print out the new line mark, okay? And each one of them, you print them. It goes to every single cell, you print them, okay? So this one, we will print matrix. So here we actually will do print matrix of n first, okay? And then we will do shift left, okay. It's area shift. So we will area shift my array m. Okay, so this one you ship everything to the lab. You have 3 rows, so your result should be it shipped to the lab. You should have 2, 3, 1, 4, 5. I'm sorry, 5, 6, 4, and then 8, 9, 7. Okay, you ship every single one to the lab. Okay, every row to the lab. So this one, okay, this one, we will ship area ship to the lab, and then we will print out the matrix one more time. Okay, and we'll do that. So each one of the row is the same as you do area ship of a array. So basically, you ship every row. Okay? You ship every row. So basically, you do for integer r equals 0. Okay, r less than m the length and r increase. Okay, and you need to ship the row to the left. Okay, so you can either call the function here. Okay, you can call the ship depth of the array function over here. Okay, you can do that. So let's try it first. So let's copy and actually just ship this one by one. Okay. Ship each row. Okay, ship each row. And then when we finish, we'll return and okay, so this one, okay, ship every row. Okay, every single row is shipped to the lab. So let's try this one. This will perform area ship. Okay. So originally you have 1, 2, 3, 4, 5, 6. You actually ship to the lab. Okay, you ship to the lab. Okay, so that one actually is okay. Let me actually copy a print. Okay, print line. Okay, so this one is area ship. You can also pick up the just like rewriting the ship depth function. Okay, so you can rewrite that. Okay, so we actually pick up the first element. Okay, to 10. So m's rows 0 pickup. Okay, and then for integer column equals 0. Okay, column less than m r the length. Okay, and then column increase. So each column will do the following thing. Okay, we will actually get started from number 1. We ship to the lab. Okay, so we say mr's lab row. Okay, and then c, okay, -1 will be equals m r. Okay, and c. Okay, and at the very end of the row, we actually have m's, r's. Okay, m's, r's. MR's MR dot length -1 will be equals 10 value. Okay, this one will perform area shift to the left. Okay. Okay, so it will shift to the left. Okay, so be the same as I call a single shift left function. Okay, it's called a single shift left function. So far, any question? So far, any question? So let me attach the swap function. Okay, you must remember that. Okay, you must try to memorize them. Hear me? This different algorithm, you must memorize it. There's no better way to learn FRQ. Okay, basic algorithm, you must memorize them by heart. Okay, must memorize them by heart. Any question? Amy, Zhao, are you okay?
Yeah.
Must memorize it. So let me copy the code to the group. Okay, and okay, make sure that you. Okay, so swap. I just post the swap. Java. Okay, I just post that. So let me finish the ship area function to the right. Okay, so here I come from single swap, and then I do ship function for single row. Okay, now I'm shifting for the whole matrix. Okay, so each one of them you must be able to recreate it by yourself. Okay, so this one I'm going to shift to the right one more time. Okay, so here let me actually do shift to the right one more time. Okay, so here let's shift to the right, the matrix shift to the right. Okay, and we will print it one more time. Okay, so go back to here, we need to shift to the right, so we do rotate. Okay, each right now also every row. Okay, so row from 0. Okay, row less than ends that length. Okay, and then row increase. So this one is for each row. For each row, again, I can simply call the function called shift to the right for each row. Okay, so this will solve the problem. Okay, will solve the problem. Each row you just shift them, and eventually you return the matrix n. Okay, so this one will work. So you shift to the left, now you shift back to the right. Okay, so you go back to original matrix. Okay, now this one, you can also rewrite it using for each row. Okay, so you pick up the last element first. There's a temp equals m's r. Okay, mr's m dot m's r dot length minus the last element you pick up. Okay, so for integer I equals m's r. I'm sorry, m's r the length minus 2. Okay, I greater equals 0. Okay, I decrease. Okay, so this one you need to copy from left to right. Okay, copy from left to right. So your m's, r's, okay, I plus 1 value would be equals your m's, r's, i's value. Okay. Here let's change to C for column. Okay, let's change to C for column. Okay, and at the very end of each row, you kind of assigning the value. Okay, and actually you put the 10 value back to there. Okay, and this one will complete left shifting for the whole area. Okay, still the same. Okay, still the same. So this one, the whole shifting and swapping algorithm, I kind of try my best to memorize for you. Okay, please take a look on them. Okay, I'm memorizing them. Okay, you see, I do not look at any book for this different algorithm. I just keep writing. Any questions? Any questions so far? About William, sorry, are you okay, William? Hear me? Any question? Okay, I'm trying to my best to teach you how to memorize them. Okay, you must have the idea and then keep try to get the key idea and then remember every single algorithm's main computing core. Okay, so these different one are based on the rotational swap. Okay, based on the rotational swap, we developing the shift left, shift right different algorithm. Okay. How about Katie? Katie, wait, are you okay? Hello.
Yeah, okay.
Any questions so far?
No, I think I understand.
Okay. So this different one must remember that, okay? Okay, so this one is shifting and swapping. Okay, we finished that. Okay. The next one let's actually try to. Last time we talked about sorting already. Okay, so sorting, there are several different swapping algorithm as well. Okay, so those things you need to remember. Okay, you need to remember. So here, let's actually look at the so-called copy algorithm. Okay, so this one, let's look at the. Okay, this one, let's look at the so-called different copying technique. Okay, so let's look at mirror. Okay, so mirror, we have different metric. So let's assume that we have a metric. Okay, this metric, let's grab this one M over. Okay, so pre-metric we also need it. So let's actually get this pre-metric as well. Okay, so we grab this whole thing for the mirror. Okay. Okay, so this one, put it over here. We have 1, 2, 3. Okay. And then 4 and then 5. Okay. And here we have 6, 7, 8, 9, okay, 10. Okay, this one we have 11, 12, 13, 14, 15. Okay. And then we have 16, 17, 18, 19, 20. Okay. Okay, and then we have 21, 22, 23, 24, 25. Okay, that's actually have this metric and we can print it out. Okay, so let's have public, okay, static, okay, void main. Okay, so here we have this one. Okay, and then we do system.out.void. Okay, and then so I'm /f. Okay, so here let's do print metric of the M first. Okay, now we print it, and then the next one what we would do is, okay, this is our metric. So what I want to do right now would be, how about this? Can we do this? Can we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we do swapping across in this diagonal line? Okay, so the result will be 1, 4, 7. Okay, 2, 5, and then this one will be A, and then 3, A, 3, 6, okay, and 9. Okay, can we do swapping across in the diagonal line? Okay, can we do that? So this one, let's see, Eric U. Okay, Eric, how can we do that?
Sorry, how can we do what again?
How can we do swapping with respect to the diagonal line?
We could use indexes.
How to use index to swap it?
Well, the first one there, that will be a 0, 0. Then we just add both values of the indexes. We increment both sides of the index.
No. How about Oscar? How can we do that?
Could you like do some sort of formula using the width and the length and then the position that you want to swap? So like if you wanted to swap 6 and 2, you would look at 6's position, and then you would subtract it from, I think, the total number of columns, and then you would go to that like specific row spot.
Oh, not exactly. Okay. I don't get your point actually. Okay. How about Damon? Damon Win.
I was actually thinking kind of similar to the whoever was saying using the index. I can't really think of anything else other than that.
But how to use index?
I guess you just write uh to for loop, just like looping every index. When when the column and the row equals to each other, you just swap with the next one that equals to.
You swap the column equal row, so you swap these.
Yes.
No, we need to swap 2 and 6.
Oh,
11 and this one.
I thought you meant to swap
across
1, 7.
Across into the diagonal line. Hey, everybody, please pay attention, okay? We are having a class. I try to explain something, so pay more attention. Look like a lot of you actually not even do not know what I'm talking about. What is the question? Okay. So what I say actually is we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this second time I talk about it. You actually try to swap across the diagonal line. Okay. And you do traversal through the whole array. It won't happen. Okay. It doesn't. You won't solve the problem in this way. How to solve it? Anybody know?
Can you like go through like travel through the array and then swap the row and column?
Which part of the array?
Like you use the nested for loop stuff, and then like for example with like array 1, like row 1.
Okay, swapping the row and column data is okay, but we cannot do over swap. Okay, so why I'm actually asking this question is this problem actually last week when we reviewed the AP ComSci lab, I do talk about it already. Okay, this one, so look like last week not a lot of students pay attention to it. Okay, my question is not asking the question that I'm asking. I'm asking another problem that how many of you really pay attention to the class right now? Okay, this is the same problem actually. I talked about it last week already. I really talked about it last week already when we talk about the review problem. Okay, I can point out which problem we talked about last week. Okay. Now last week we actually goes to actually we work on the algorithm. So we work on the AP lab. Okay, we work on the AP lab. So we go to the Barron's chapter 10. Okay, so chapter 10 there is a Barron's chapter 10 problem, and there is a problem actually working on that. Okay, working on that diagonal swapping problem, and I told you. Similar to the reverse of the array, you have 1, 2, 3, 4, 5. So you cannot do swapping this one, swapping this one. Okay, you swap this is enough. Okay, you become 5, 1 for the first swap. Second one, you have 4, 3. That's the second swap. Okay, 4, 2, second one, and then you have 3. So you stop there. That's fine. Okay, you swap here, here is fine. And if you continue to swap, you will swap 3 with 3, that's okay. And then you swap 2 and 4 back to here, okay? And then you continue to swap, you swap over. So you cannot go through every element in the array. Then you will do over swapping, okay? You will do over swapping. So this one, we talked about it last week in the class, and we also work on the problem set, okay? Barron's problem set last week. And the problem we do talk about, there's one problem in this AP lab, and I talk about it saying that if we need to do diagonal swapping, you can only swap in the upper triangle or lower triangle. okay, you need to traverse only through the upper triangle or lower triangle. And we do talk about this last week, okay? We do talk about the swapping of the upper triangle and lower triangle, okay? So that is this problem. Last time is not swapping, it's actually copy from here to here, from here to here, from here to here. It's not swapping. So in that case, we will end up with A. This is the problem we reviewed last week, okay? So I talk about it, when you do traversal, you only traverse the lower triangle or upper triangle. But this week, I hear no one actually remember it, okay? That this is a serious problem, okay? This actually is a serious problem. So let's actually do, okay, public static, okay, void swap alone, okay, a diagonal. Okay, this is not an easy problem. Yes, it's not easy, but we do cover it last week, okay? So this one, you need to swap, actually only go through the upper triangle or lower triangle. So let's actually review the upper triangle one more time. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to swap this one, this one, this one. This one swap with this one. This one swap with this one. This one swap with this one. And you will get 2 and 4, 3 and 7, 6 and 8. Swap it. Then you'll be fine. If you continue to do every single cell, you will fail. Okay, so you only go through the index for the upper triangle. So upper triangle is the triangle on the upper side, but not including the diagonal items. Okay, it's actually over here. So your row starting from 0 go down to 1. Okay, the last row you don't touch it. Okay, column starting from row plus 1 until the end of the array. Okay, so that's the way we actually work on the index. Okay, so that's the upper triangle. So we need to swap through the upper triangle. So for integer row equals 0, okay, row less than m the length. This traverse each row to the last row. You do not actually do traverse, okay. And here you go through every single column, okay. Your column starting from r plus 1, okay, and your column less than m's r, okay, that length, okay, this one go through the last one, for your column, okay, so column increase. Now you need to swap the cell. This 2 cell is, okay, here you have 1, 2, 3. So this one is actually row 0, column 1. You need to swap with this guy. This guy is row 1, column 0. So you need to swap with the element from the row and column to column and row. Okay, that's what you need to swap to. So here we do rotational swap, integer, okay, row, I'm sorry, m, actually temp, okay. Temp value should be rows, I'm sorry, it should be m's row and the column. You back up this one, m's row and column will be equals m's, okay, column and row. This one you swap, actually you change the row and column, okay. And the last one you have m's column and row coming from the temp value, okay. So you finish that, that's done, okay. So let's do system.out.print line, and then we print the matrix one more time. Okay, after we do such diagonal swap, we print it one more time, okay. So here I'm going to swap this one, swap along the diagonal line, okay. This one, we really discussed it last week, Okay, we really discussed it last week. I'm not kidding. Okay, it's not simple one, but we do discuss it. Okay, so this one is mirror. So mirror, we kind of from the row, okay, it actually been a copy to this side. Okay, so basically your 2 and 6 swap, your 3 and 11 swap, okay, your 4 and the 16 swap, something like that. Okay, is that okay? Must pay attention to the class. Okay, we are discussing something useful. Okay, so first one is a swap crossing the diagonal line. See right here, we're starting from swapping two numbers, right? And then we do shifting. We do shift right, shift left, and then we do area shift left, area shift right. Okay, and now we actually swap in the diagonal term. Okay, so now next one we will swap. Okay, we will do swapping. Okay, basic flip over horizontally and flip over vertically. Okay, so let's try this horizontal, flip over horizontal one first and then vertical. Okay, so swap vertical and swap horizontal. Okay. So each copy is also possibly swapping. So right here, let's assuming that we actually do this this one. Let's call this one vertical. Okay, so you actually need to swap this. Okay, so each one of them you need to go through only half of it, but you need to iterate through every row. Okay, every row. So outer loop, you need to go for integer r equals 0. Okay, r less than m the length. Okay, r increase. Okay, and then for each, then you have each row. Each row of them, you would have 1, 2, 3, 4, 5. Okay, you need to swap. Okay, you do up to the middle. Okay, up to the middle. So for c equals 0. Okay, c less than m of the r the length. Okay, divided by 2, and then c increase. So you go only half the way, and you will do swapping. So you pick up your temp value, okay, and then this one you have a certain cell. This one is called M, row and column. Okay, so who know which cell you should swap with in order to swap vertically? Anyone remember? Natasha, are you okay? Which cell you need to swap with it?
Sorry, what was your question?
The question is which cell need to be swapped with MRC in order to flip along the vertical axle in the middle?
The second.
That's the symmetric location, okay? Must remember that you are same row, but your symmetric location. So M's are, okay, the length, okay, -1 minus C, okay, should be the cell, okay? So this one you will copy to your MRC, will get the data from there, okay? And then eventually you M and this cell would get the value from 10, okay? And this one was swap vertically, okay? And this different algorithm is very important when you go to FRQ, they may test you this, okay? let me test you this. We did not print it yet. Okay, so let's actually do this. Let's actually do one more time. So here that's actually called swap vertically. Okay, so swap vertically. And pre-metric, and then actually, okay, pre-metric, and then this one was swap vertically. Okay. Okay, so here from this one to this one, we do swap in the middle. Is okay? Any question? Any question? Any question about this swap vertical? The code is not super long, okay? So you must, okay, you don't remember, that's fine, okay, that's fine. You still have 2 weeks. So what you should do is that after class, please read through the code that I give you and try to memorize it. Is okay? Try to memorize it. And today's topic is to copy, paste to different array, go one by one, okay? We are working on this swapping, shifting, different algorithm. We working on this different algorithm. We starting from swap, and we do vertical, horizontal one. Okay, so this one, swap vertical. So let's work on another one. It's actually swapping horizontally. Okay. Swapping horizontally is actually also similar. So let's actually look at the 3x3 metric. Okay, 3x3 metric, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go through each, we will swap here with the row. Okay, so I go through every column, and then I try to swap to the middle. Okay, so that's the plan. That's a plan we have. Okay, that's a plan we have. So before you write the algorithm, you must have some sort of plan. So here for each column, so integer column starting from 0 and column less than m. Here you do not have R to use, so use M0. Okay, that will tell you the number of the column, number of elements in the column, how many columns they are. Okay, they will give you this number, how many columns they are. So you go through every column, and then you kind of need to do swapping, but you only swap up to the middle. So you are starting from 0, R less than M, the length, okay, divided by 2. Okay, only half of the row you will do swapping, and R will increase. Okay, and right here you actually do swapping. So here you have integer temp will be equals the cell at the MRC location. Okay, and this MRC will assign the value from its symmetry location. So it's actually M. Here the symmetry location is not a column. Column will be the same. Will be in the same column. So you do have, say, 1, 2, 3. So you need to swap these 2. Okay, so you need to find its symmetric location in the column. So that one should be your M's R. Okay, that length. Okay, I'm sorry. Here will be your M, the length. Okay, that is the number of row, -1, -R. That's your symmetric location. Okay. M dot length minus this one M. Okay, and then your value of this one should be equals 10. Okay, let's say it's swapping horizontally. So copy, put it over here. Okay, and then we copy this one, print, and actually swap horizontally. Okay. Okay, so this one, this one original data is this one. You do swapping across the horizontal line. Is okay? Any question? Any question about this one? If you don't know, that's fine, okay? But please try to memorize it, okay? In the short time, that's the best way you can pick up things. So let me copy this mirror program to you. Any question? Hi, Amy, are you okay?
Yeah.
Yeah. Not that hard, okay? The core is still the swapping algorithm, okay? We never change. Today's topic is everything related to swapping, okay? Related to swapping, okay? Today, our main topic is everything related to swapping. So we do diagonal swapping, we do vertical swapping, we do horizontal swapping. Okay, it's possible that we actually do swapping over here. The reverse diagonal, we actually swap from here to here. Is that possible? Yes, it's possible. Okay, it's possible. So here, if we do this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so you will do across the line. You swap this one with this one, this one with this one. Okay, this one with this one, this one with this one. Okay, this one with this one. Okay, this one, this one. Okay, so let's assume that this one is called R and C on this cell, right? So this guy would be what? This guy would be the width, okay, number of the, this one would be number of the row, okay, minus 1 minus R. So this one is n minus 1 minus R, okay? N is number of the row, okay? And then the column would be m minus 1 minus column, okay? You basically swap them in this way, okay? And you do traversal so that your row starting from 0, okay, to what? To actually n minus 1. Your column starting from 0, and then a column need to less than row, okay? I'm sorry here, I'm sorry, okay? So this one actually row plus column, okay, need to be less than 4, okay? 4 is the number, number of the column, so actually less than 4 minus 1, okay? Need to be less than 4 plus 1. So right here, this one actually is from row column 1, column 0, column 1, column 2. Okay, so it actually is 2 less than 3. Okay, you are up to there. Is that okay? Is that okay? So this line is called row plus C equals 3. Okay. Equals 3, equals 4 minus 1. This one is that, and this whole thing over here, that is a smaller row. Okay, let's do this one. Actually, it's called swapping a back diagonal. Okay, so let me put it over here. Okay, this one is back diagonal. Remember, it was would be go through every single row. So integer row equals 0. Okay, row less than m the length. Okay, minus 1. The last one we don't touch it. Okay, and then row increase. Okay, and then column will be for integer or column starting from equals 0. Okay, and then you have the row plus c less than m the length. Minus 1. Okay, m the length minus 1 would be 3. Okay, but your sum need to be less than that. Okay, so c increase. If that condition happen, you will stop. So now you actually will be swapping. So you will swap the temp value. Okay, your RC, so your M of the R and C will getting the value from, okay, you're getting the value from M's, okay. Your N, okay, is actually M dot length, okay, minus 1 minus R, okay, and then your M's, okay, R dot length, okay, minus 1 minus C, okay, this location. And this one, you kind of get the value from the temp. Okay, that's it. That would do backward diagonal swapping. Okay, and that's call this function. Okay, pre-metric and then swap them. Okay. Okay, and that's actually wrong. Okay. So this one, let's see here. Okay, we kind of it over here. This one actually. Okay, it's actually this one horizontal. I'm sorry. Okay, this one should not be horizontal. This one should be swap back diagonal. Okay, let's run this one more time. Okay. Okay, so this one you see it actually will swap along this line 1 and 25 swap 6 and here you have 6 and 24. Let's see. 6 and 24. Wait. Let's see. Mirror. Okay, so here we have swap horizontal. We print that. Okay, let's see. This one we have pre-metric. Okay. It actually, let's see, no. 5, 9, 13, 17, 13, okay. So you one swap with 25, you two swap with 24, okay. So you two swap with 24 here, okay. And you 3 swap with 23, okay. 4 swap with actually this 24, okay. So here it actually swap to the middle, okay, swap to the middle. So the swap engine right now actually is wrong, okay. Let me modify it a little bit, okay. So here this one we have the RC, okay. So how about this one? This one we have row 0 and 3, okay. We will swap with this guy. It actually is row 1, okay. And then column will be 4, okay. So this one 3 swap with 4, and then 0 swap with 4. Okay, so the number need to be swap. Okay, number need to be swapped as well. So here let me make a little change. Okay, so this 2 should be swapping this guy. Okay, so right here it actually should be your RC. So this one should be, let me cut this one. Okay, cut this one to the end. Okay, cut this one to the end. Cut this one. Okay, the column and rows number actually swap. Okay, so that was swap to your swap along this line. Okay, swap along this line. But you kind of need to swap its index for the swap location as well. Okay, this one is more advanced. Okay, this one more advanced. And there's another swap. We just see that is swap by the center. Okay, so there's another function that's called swap by the center. Swap by the center is according to the center of the matrix. Okay, swap by center. Okay, so swap by center would be swapping by the center. That one is the one we just done it. Okay, so that's actually swap the location we have. Okay, cut this one. Okay, let's call it swap by center. Okay, I don't think the last 2 they will test you. Okay, but the previous few maybe. Okay, previous few maybe. But the last 2 I think is a little bit too hard. Okay, but just give you the algorithm so you can study. Okay. Okay, these are the swapping algorithm. I have already give you all possible toughest possible swapping algorithm. Okay, this one swapping the center. That means you swap this guy with this guy. Okay, and then you swap 3 and the 23 is over here. Okay, you swap 4 and 22. Okay, these are these 2. Okay, swap across the center. Okay, swap across the center. Okay, that's mirror. Okay, that's mirror. We finish the mirror. Okay, next one, we are going to go through the different copy. Okay, so before we do that, okay, let's work on one problem together. Okay, this one a problem together. I'll give you some time. Okay, so this one we will assign 1 to 25 into an array. Okay, so this array has 0 to 24 for each 25 elements. Okay, in the middle you will assign 1. Okay, so in this case, it should be number 12, you assign 1. Number 11, you assign 2. Number 13, you assign 3. So basically, you do this way: 1, 2, 3, 4, 5, 6, 7. Okay, and then keep doing that until this one is 24 on the 0 location. And then here you have 25 on the index location 24. Is that okay? Can everybody work on this problem? Bring your editor to try this problem, okay? Amy, hear me?
Yeah.
I'll try to help you, okay? Everybody, I'll try to help. How about Damon? Are you okay? Bring up your editor, try this problem. You assign a value with the 1 in the middle. 1 in the middle, and then 2 on the left side, 3 on the right side, 4 on the left side, 5 on the right side. Keep doing that until you have 25 elements. So assign 1, 2, 3, 4, 5, 6, 7, 8 until 25. Is that okay? Hear me? How about Eric? You hear me?
Yeah, I'm working on that problem.
Okay, thank you. How about James? Are you okay?
Yeah.
Okay, I'll make sure everybody hear it, okay? How about Natasha? Are you okay?
Yeah, I'm okay.
Okay. How about Oscar? Are you okay?
Wait, I was grabbing my charger when you explained the problem statement, so could you summarize it? Sorry.
The problem is you assign, here we have array of 25 elements, index from 0 to 24. You assign 1 in the middle, and then 2 on the left, 3 on the right of the 1, and then 4 on the left of the 2, and 5 on the right of 3. Keep doing that until every single cell being filled with some number. So that would be 1, 2, 3, 4, 5, up to 25. But 24 will happen on the index 0 location. 25 will happen on index 24 location. Is that okay?
Yeah, thank you.
Try doing this one. How about Oscar? Are you okay?
Oh, yeah.
How about William? Are you okay?
Yeah.
Okay, do it, okay? And I'll come back, give you about 15 minutes to work on it, okay? And we'll discuss it. I'll look at everybody's call, okay? Give you 15 minutes to work on it, okay? And by doing this one, I will know how good you are in coding, okay? Give you 15 minutes. So right now it's 7:05. We'll check on 7:20, okay? And I will give you my mirror program, okay? Okay, I'll upload my mirror program one more time. Remember, all of the program we talk about it today are okay to test in the AP, okay?
Is 0 to 25 or 1 to 25?
Hello, any question?
Is it 0 to 25 or 1 to 25?
1 to 25. You have 25 elements, index from 0 to 24. So you'll be 1 to 25. Right? Is that okay?
Yeah.
Any question?
I have a question.
Yes.
So once I'm done with my program, should I save it into a file?
You should save it to a file. Yes, send to me. You can send me to email to me. You can send to ECHOU 510. 510 is my area code, okay? At gmail.com, okay? And write down your name, okay? There are several ways to write this problem. Okay? It is not only one. There are several ways to work on this problem. Okay.
I have a question.
Yes.
Just to confirm, I need to print out an array just like the one drawn out on the screen right now, right?
Yeah.
Yeah.
Print it out like this to prove that your program work, right? So this one will actually give you many techniques to make it work. Okay, I'll try when I explain it. I'll try at least two ways to show you how to do it. Okay, this is more than one way to solve the problem. Now, there's not only one way you can do this problem. Okay. And in a way, I'm guessing this might be the problem of this year's AP exam. Okay, this is the problem I guess may happen.
I have a question.
Yes.
The number next to the 4, is that a 6 or a 16?
Six. It's
Oh,
1, 2, 3, 4,
okay.
5, 6. It's continuing number 1, 2, 3, 4, 5. So one in the middle, then 2, 3, 4, 5, 6, 7, 8, 9, something like that. Is that okay?
Yeah. I sent my solution to the email address.
You sent to my email address already?
Yeah.
Thank you.
I think it's correct.
Thank you. Yeah, I see it. Okay, thank you. try to work on more FRQ problem, okay? And we try to grade you, but you really need to practice more. Okay. And do not copy, okay? Some student copy is not a good habit. You lose your chance to practice, okay? Okay. Aaron, your program work, okay? Your program work, but it's actually designed for this array. So if the size change, your program need to be updated, right?
Yeah.
Yeah, it's okay. But at least it's a working way. Any question? Anybody has question on this one? Hey, Amy, are you okay?
Yeah, I read the problem wrong, so I have to restart.
Are you okay so far?
Yeah,
Knowing what to do so far?
yeah,
How about Damon? Are you okay? Hi, Damon. How about James? Are you okay?
I think so. Are we supposed to use swap to make this code? Or
How about Natasha? Are you okay? Any question? Hello?
I'm okay.
You are okay?
Yeah.
When you finish, please send to my email account. Right? This one, for AP student, I won't say it's easy, okay? It actually is okay problem, not too easy, not too hard. How about Oscar? Are you okay?
Yeah, I'm almost done.
Almost done. Okay, please submit, okay? Please submit. We have 1 more minute to go. I know the regular exam, it will be 22.5 minutes you can do, okay? You have 4 problems. Each one of them, you have you have 22.5 minutes you can work on, okay? Here we use 15, but it's okay. I think you guys are okay. If you can almost solve it, should be fine, okay? Please send to my account, okay? So now it's already 7:20, okay? How about William Zai? Are you okay?
Yeah,
Any question?
not really.
Okay, if you are done, please just send it to my email, okay? ECHOU@510@gmail.com, okay? Please send that, okay?
All right.
Now I'm going back to discuss this problem, how to solve it, okay? How to solve it. So this one, first, let me take a picture on the problem, okay? So I'll post it to the group, okay, using the checkbox, okay? Using the checkbox. So this one is the problem. So how to solve it? There are several ways you can solve it, okay? There are several ways you can solve it. Let me post it, okay? Sorry. The Zoom doesn't allow post and pass, so I need to go to the hard disk to get it, okay? Sorry for that. Okay, so this is the problem. Okay, now let's work on it. So let me clear it, okay? Let me clear it, clear this discussion page, okay? Let me clear it. I said it. So here you actually can get started. One way you can get started is you starting from the middle. So you have 25 elements. How to calculate the middle? Okay, the first thing you need to calculate the middle. Middle for odd number is equal to n divided by 2. Okay, this one we teach you several times. Okay, if it's even number, n divided by 2 will be the right size middle one. Okay, if odd number, m divided by 2 would be in the right middle. Okay, so you need to use that. Then you start to copy 1, and then copy 2, and then copy 3. Okay, so what I could tell you is that 1 you will copy to here in the middle with 0 distance. And then I increase the distance to 1, I copy to the left. And then I increase by 2 of the index, I will copy to 3. I'll increase by 1, that will copy the distance of 3 to the left for 4. Keep doing that, I will solve the problem, okay? Keep doing that, I will solve the problem. So this one is the first answer I can have. So this one, actually, let's call it actually symmetric, okay, array. Let's call this one symmetric array, okay? So this one, we have a number, this number called integer n, okay? So this integer n equals 25 for the time being, okay? Okay, so this one we will have the function public static, okay, creating an array, okay, and generate, okay, S array, okay, SA. So generate array, let's call it generate array, okay? So integer, you will take the number n into it, okay? Okay, right now n is 25, so you will create a integer array, okay, A, it will be equals new integer array of the number of element n, okay, and at the very end, you will return this A back, okay. So right now we started to from using the integer data. So data I start to use actually 1, okay. So totally I'm going to do it for 25 times. So I'm going to do I equals 0, I less than n, okay, I increase. So I'm going to do 25 times. So this I only counting for 25 times, okay. Starting data is 1, okay. And then starting step size actually is 0, okay. And then next one, okay, next one, your current pointer, integer pointer will be, your direction will be equals 1, okay. So every time you change direction, so your direction will time equals -1. Your positive number will become negative, your negative number will become positive, okay. So here your A's, okay, you should have a current pointer. So the current pointer integer pointer P should be n divided by 2, okay. So your current pointer value, okay, will be equals, or okay, you need to calculate your current pointer value. Okay, so your current pointer value will equals direction times the step size. Okay, so every time your step size will increase. Step size originally 1, 0, and then 2, and then 3, and then 4. So first one is 0 times 1 times 0. 1 times 0 is 0. P is still remaining 0. Second time you have -1 times 1. Okay, and then your P will become from middle value to the left side, and that guy will be data equals data increase. Data you assign 1 to that value, and after that you keep assigning 2, 3, 4, 5 to it. Does that make sense? That's it. Okay, that's it. Okay, this is my guess of the problem might be tested this year. Okay. Okay, let's run it. And it just work. Is that okay? Any question? So let's try 33. And it still be working. Okay, 33 is still be working. This one is version 1. Okay, so let's drop down to 5. It should still work. Okay. Okay, any question? Any question? So what do we learn from here? Okay. How to control your index. Okay. Your index, the index I'm using right now is every time I starting from the middle. Okay, the first one I actually increase by 0. Direction right. Okay. And the next one I increase by 1, but direction to the negative side. Next one I increase by 2, but direction to the plus side. Next one I increase the index by 3, but direction will be the negative side. By doing that, actually I assign the value spread out left, right, left, right, left, right, left, right, and then the whole thing will be assigned. Is that okay? Any question? Eric, is that okay?
Yeah, that's okay.
Let's try different way. Okay, let's try different way. This one, let's have another one. Public, okay, static, okay, integer array. Let's work on generate array. Okay, number 2. Okay, so this one we take the integer n in one more time. Okay, so right here, this one we will have the array A. Okay, we will still need that. So we do integer array A equals new integer array n. Okay, and then here we return A back. Okay, so this one no problem. And here I will say integer middle value will be equals n divided by 2. Okay, and then for, and that actually its middle value, it also is what? The middle value is the value that in the middle. It is also the size of the left side and the right side. It's also the left side and right side. So this one, let's do this one. Let's do here, okay? So here for integer I equals 0, I that's the middle value, I increase. So totally I'm going to do 12 times on the left, 12 times on the right, okay? So I'm going to do A's, okay? A's middle value plus I, minus I, okay, minus I. Okay, minus I, and then minus I minus 1, okay? So here you're starting from 0 to the middle value. So let's change it, okay? Let's change it. Let's change it to 1, okay, to middle value, okay? So this one minus I, is minus I value will be equal, so right here, our A's middle value, okay, middle value will be equal 0. So that's assign data to it. So initial value data will be equals 0. Okay, we assign value. And after that, I will assign data plus plus to mid value. And then I say my right side mid value plus I, it will be also data plus plus. Okay, that's it. Okay, this one is the second way to do it. Okay, so here let's actually do this one. Let me clean it. Okay, let me clean it. So every time you see these two that way will create the same answer. Okay, it create the same answer. So let me put the 25 back. Okay. Okay, the same. Are you okay with the second solution? Anybody okay for the second solution? Here should be starting from 1. Okay. Here I should have the. I did not call this one. Okay, sorry for that. So here I need to copy and then paste here. Generate array 2. Okay, I did not generate it. Sorry for that. Okay, one more time. Okay, I actually copy, print out the same data. Okay, sorry for that. Okay, this one actually, no, it's wrong. Okay, let me try again. So here, okay, here, let's actually look at it. Okay, so here this one should be data. Okay, let's actually have data equals 1. And then here I should plus, okay. Let's look at it this way. Okay, then this is okay. Sorry for that. Any question here? So this one, same thing. Initially, I calculated middle value. In the middle value, I put a 1 over there. That's actually number 12, okay? After that, I do 12 times. So left side, I have 12 number, right side, I have 12 number. So I start to assign a value to it. So after the first assignment, I increase to 2. So left side, I put a 2 there. Right side, I put a 3 over there. And keep doing that. Okay. Every time the distance keep increasing by 1. Okay. Any question? Okay, maybe like this. Okay, maybe they assign a value 1, 2, 3, 4 like this. Okay, maybe it's possible they work out some problem in a reverse way. Okay. Any question? Okay, anyway, this one I again posted to the group, okay? So any one of you finish it already? Other than Eric, you, okay? Anyone's finished already? No one? Okay, please practice more question, okay? It's not a super hard problem. Please practice more. Okay, so that is some problem we work on so far. Okay, so there are copy algorithm. You can copy 1 dimension, 2 dimension. Okay, doing different way to do traversal. Okay, so you can copy array to different location. Okay, okay, and then you have the 1 dimension to 2 dimension copy. Okay, so let's try another one. Okay, let's try another one, another problem to solve. Okay, so this one, let's try a simpler one. Let's actually do this. Okay. Let's generate a column major matrix. But in this way, is okay? So your row 0 is here, 1 here, 2 here, 3 here. Column 0 here, 1, 2, 3. Okay. This one, same thing. I'll give you 15 minutes. Okay. Any question?
You repeat the problem.
Hmm?
Can you repeat the problem?
The problem is to assign the number 1, 2, 3, 4, 5 according to the order we shown in the picture. Column major, you get started from the last column on the right first, and then going back to the column 0, starting from column 3, you assign the value, and then going back to column 0. But you need to assign 1, 2, 3, 4, 5 up to 16 to it. You using the 4x4 matrix. Is that okay? Any question? Hi, Amy, are you okay?
Yeah,
Can you understand the problem?
yeah.
Okay. Work on it, okay? So right now we are 7:40, so that actually go to 7:55, okay? I'll look at your solution at 7:55 p.m., okay? Work on this problem. column major traversal, starting from big column to the smaller column, okay? If you are not able to do such a problem, that means your knowledge about a two-dimensional array or one-dimensional array or index is not enough, okay? You better try harder to review them, okay? Try to write more programs. That's the only thing you have to do. And these problems, what I am trying to create are of AP difficulty, okay? I'm not assigning super hard problem. So for Damon, I got your submission, okay? And you did not go through the problem in the right way. We need to assign 1, 2, 3, 4, 5 to the right location. You just using the metric to do it. It's not the right answer, okay? Damon, hear me?
Yeah, I will redo it.
Okay, for Oscar, your program should work, okay? Hear me?
Yeah.
Okay, your program should work. I know you need some polish, but it's okay. Overall, I believe it should work, okay? Thank you. Thanks for both of you to submit, okay? So here today, we practice more one-dimensional array, two-dimensional array, okay? The purpose for doing that, this actually take up about half of the problem in the FRQ portion, okay? If you are able to handle them well, you are okay. You're basically okay. So this type of problem, no matter it's column major, row major, or index from small to large, large to small, you must practice it well, okay? And also the mapping algorithm from left to right, right to left, diagonal, reverse diagonal, different kind of combination. Please after class also practice them, okay? Okay, anyone have done this problem other than James, right? James submitted. Oscar, I'm sorry. Other than Oscar, any other student already finished it? No? We'll go ahead, okay? How about Amy? Are you okay?
Yeah.
Okay, here I copy the problem, okay? After class, you need to look at it one more time, okay? I try my best. So I copy, actually I take a picture on the problem. I post it to the chat box, okay? So you actually look at the problem. So this one, compared to previous one, I would say this one should be easier compared to previous one, okay? Compared to previous one, it should be easier. So this one, let's call it column, okay, major. Okay, column major, and that's actually copy the metric copying program, okay, printing program. So that's actually had the print metric program, okay? Print metric program. So we do column major, but we have this, okay? So, okay, so let's get started. So here we would have a public, okay, static, okay, generate, it will return the metric, okay, so generate metric, okay. So the generate metric, we will have integer, let's assume that it actually is n again, okay, so that's assume it's n now is 4 by 4. So the integer will be, actually we will create integer metric n to be equals new integer, okay, it will be 4 times 4, okay, so 4 by 4. We create a 4 by 4, okay, and then number, okay, so size, let's have the size should be n by n, okay, we do that. So now we go through each individual column, so integer column, we're starting from the big one. So big one should be n minus 1, okay, and then c greater equals 0, c decrease, okay. So we do that. And then let's just see from big to small, okay. And the column, I'm sorry, column from big to small, and then row from small to large, okay. So row will be equals n, okay, from 0, okay, and then row less than n, okay, and row increase. Okay, and then after that, we actually starting from, we need to have a pointer, okay, so integer data, again, this one starting from 1, okay. and we will assign to M of the row and the column should be equals data increase. Okay, that's it. That actually is done. Okay, so this one, if you know how to do it, it actually is a 5 minutes problem. Okay. Okay, we talk about it is 4 by 4, so I'll use 4. Okay, I'll use 4. Then that's wrong. Okay, it's okay. It's pretty simple. This one. Any question? Any question?
Could you flip the for loops, like the order that you put them in, and it would still work? Or
Flip the order of the for loop?
yeah, like row as the first.
No, it won't work.
Row.
This is column major. It won't work.
If it's column major, don't you do C before 4? I mean before R.
C before R, yeah. C is outside.
Oh. Oh, yeah. Okay, yeah.
Okay. So this one is generate matrix, okay? So I'm going to upload the code to you anyway, okay? Try your best, okay? Try your best. Okay, another problem, okay? We keep doing that, okay? We keep doing that because we want you to review more different type of problem, okay? So next one, we would have a array, okay? We would have an array. So this array, no matter what it is, okay? I will arbitrarily give you an array. So this array, let's assume that we have an array, integer array. A, this array will be equals 4, 1, 3, 2, 10, 7, 1, 4, 5, 6, 8, 6, 5, 2, 1, 9, 8, 4, 2, 3. Okay. Given this array, that is, and you try to solve it and keep no duplicate. So please give me an answer that is, return an array that is. Is okay? Give me an array that is. So this is the input, okay? Arbitrary number, but you need to generate a sorted array, but no duplicate. No duplication. Is okay? Hi, is okay?
I have a question.
Yes, question.
So for this problem, I sort the array given here, right?
Yeah.
And I remove all the.
You don't need to call sorting. If you know how to do it, you don't need to call sorting.
Okay.
Okay.
Once I
So
sort
this one, let me give you 20 minutes this time, a little bit harder. So basically, I give you an arbitrary array. Okay, this is only one example. You can use this example to do it, but in general, you should not find a solution only for this problem. That actually is not the right answer. You should be taking any array of any size, any data in there, but we would remove the duplicate one and also sort the data. Is that okay? This one I'll give you 20 minutes to do it. Is that okay? Is that clear now?
Yeah, that's clear.
Go ahead. Okay, go ahead. William, are you okay?
Yep.
How about Oscar? Are you okay?
Yeah.
Okay, go ahead. Okay.
Wait, I have a question.
Yeah, go ahead.
So we should write a code that doesn't need to take like the size of the array to do that, right?
Doesn't take the size. You don't take the size. You should take the array in. That's it.
Oh, okay.
The function should only take the array. An array, you can find the size by array.length, so you actually know about the size as well. Okay, so this one I give you 20 minutes. So right now it's 8:05, so I'm expecting you to finish on 8:25. Okay, give you more time on this one, given the fact that this one's a little bit harder. Okay. And this one is my guess of the problem for the data manipulation. Okay. Any question? So anyone who still don't know how to do it? Anyone? Need some hint? Hey, Natasha, are you okay?
I'm okay.
Can you do this one?
Yeah, I'm working on it.
Okay. If some of you finished the previous one but you did not submit, you can still submit. Okay, I'll look at it. Give you comments. But all these different problems would give you some idea of what may be tested. Okay, you will practice some skill, needed skill for the exam. Okay. Any question so far? Okay, I'll save some time. Okay, originally I said it would be 8:25, but here I would like to save some time. So far, no submission yet, but it's okay. I'll save some time so we can do one more problem. Okay, so we can do one more problem. So this one again, I'm going to take a picture for it, and then I'm going to discuss how to solve it. Okay, I'm going to discuss how to solve it. So this one, there are also many ways you can solve this problem in a nice and easy way, okay? There are several ways you can solve it in a nice and easy way. And you just need to be aware of those methods, okay? So let's look at the very easy way, wasting memory. I will solve the problem in a very quick way, okay? So the problem I submitted to the checkbox already. So this one, let's call it packing. Okay, so you're packing things up, making it a smaller array or something. Okay, so right here we have an A. Okay, so let's do this one. Let's actually do this. Actually, we have some data. I don't know what are the data. Okay? I don't know what are the data there, and I need to pack them. I don't want them to repeat. Okay, I don't want them to repeat. So a good way, an easy way to do it is let's waste some memory. Okay, let's waste some memory. So let's do this one. Integer n max, okay, equals integer that mean value, okay, and then integer mean equals, okay, integer that max value. So you find the maximum and minimum, okay. You find the minimum and maximum, okay. And then you do what? You do this one for, okay, integer I, actually you can do this. You can do integer, okay, x from A, okay. So here, if x greater than max, okay, then max will be equal to x, okay. If actually x actually less than mean, then your mean will be equals x, okay. So you find the maximum and minimum from this array, okay. I don't do sorting, okay. I don't do sorting. I don't like sorting, so I don't do any sorting on this one, okay. I told you I'm not going to use a sorting. So I found a minimum and maximum. So here I will create a Boolean array, okay. This one called availability array, a new Boolean, okay, new Boolean value, and this one would be maximum minus minimum plus 1. Okay, that's the number of elements from minimum to maximum. Okay, that's the number of elements you have. So the smallest number would be mean. Okay, so smaller number would be mean. So for each integer x, okay, in A, okay, each x in A, okay, and then if actually you do this, okay, you do this, your Boolean, your AV, okay, your AV's x value minus mean will be equal to true. Okay. And after that, you do this, okay. After that, you do this, okay. You create integer, okay, b, okay. You create integer b, okay. And this integer b, okay. This one packing, you should return a integer array b, okay. You need to return the integer array, okay. You need to return integer. So this integer array equals new integer, and the size would be AV. That actually the size would be what? Okay, you need to determine the size now. So here you need to have a counter C equals 0. So you turn it to be true, okay. Then okay, now you cannot do this, okay. You actually cannot do this yet, okay, not yet. So here for each Boolean value, okay, b, okay, from your AV, okay. So here you need to have an integer counter. Okay, integer counter. Okay, so integer counter you would be equals 0. Okay, so right here you would have if, okay, if b, okay, and then c increase. So you would check how many positive number are in the AB array. Okay, now that's the number of the element you have, distinct value you have in the array. Okay, so you create a integer array B. Okay, this one that's called D. Okay, D, new integer array. The size will be C. Okay, the size will be C. Then you do for, okay, each Boolean value. Let us do this for integer I equals 0. Okay, I less than AB dot length. Okay, I increase. Okay, I increase. So here you would do this one. You would have, you should have a running index integer P equals 0. Okay, and here you should if, okay, if AB's I's value is true, okay, then what you would do is actually you would D of the P plus plus will be equals your min plus I, okay, and then at the end you return D. Okay, and what am I doing right here? Okay, let's actually go through it one more time to see what am I doing right here. I'm doing packing. Okay, I'm doing packing, and I do not use any sorting. Do not call any sorting algorithm. I do not use any of the comparison. I don't use any comparison. So let's look at this one. I'm given an array A like this, right? I find the maximum and minimum. So my maximum is 10, minimum is 1. So I create an availability index element. So it's from 1 index from 0 to actually 1 to 10, to 10 value. So 0 to 9. Okay. So its corresponding data will be 1 to 10. Okay. That's actually my availability array. Okay, and I actually mark the data, every data from A, okay, and X minus min. So if X is 1 minus min, 0, you put a true over there. It show up, okay. So here we put several true there. If the data show up there, the duplicate data will be removed using this stage, okay. And then after that, I count how many T are there. So I know how many T, those are T number are the number we have, okay. So I count the number of T, and that is in C. So C tell me what are the data, distinct data we have. That's the number C, okay. And I create a new array that's smaller than every available list. That is each of the number that have the data. So I started from P, starting from 0. I go through the whole availability array. When it is true, that means the corresponding data is in the array. So I actually put the P plus plus value of the D with the min plus the I is the corresponding index data, okay? And with that, I should be able to pack my array, okay? No sorting at all. This is one way to solve it, okay? It's one way to solve it. So this one, I should give it packing on my array, okay? Is that okay? Does that make sense? Any question? Any question so far? Hi, Amy, are you okay?
Yeah.
Can you understand my solution?
Yeah.
Let me try one more time, okay? Don't use such a big array. Let me try one more time. Let's assume that we have 4, 4, 3, 1, 3, 2. Okay, let's actually look at such an easy array. So maximum is 4, minimum is 1. So basically, I prepare a available list. Okay, it will be 0, 1, 2, 3, totally 4 numbers. They are representing data of 1, 2, 3, 4. Okay, so then I go through it. 4, yes, 4 actually is here 2. 4 actually is 2. Okay, so this one actually will remove the duplicate. 3, 3, 2. Okay, 1, 1 actually 2. 3, 2. Okay, so here 2. 2 actually, I'm sorry, 1 should go to 0. Okay, and 2 is 2 over here. Okay, so everybody is 2. Okay, that's assume that that's actually try different one. Okay, let's assume that I don't have 1. I don't have 1, so my 0 actually will be false. Okay, will be false by in that way. Okay, and my minimum right now will become 2. Okay, will become 2. So let me try if actually 1 is missing. Okay, so we have 2. Wait. No, this doesn't work. Okay, let me change the problem. Okay, let's redo it. Okay, this one is not a good example. Let's try a different one. Okay, try a different one. That in the middle we do have some missing value. So let's try a 1, 2. Okay, 4, 5. Okay, for 5 this and then 1. Okay, for example like this. So the maximum is 5, minimum is 1. Okay, so we create our available list. The index is 0, 1, 2, 3, 4. Okay, because they are totally 5 to 1. They are 4 apart, totally 5 data. Okay, and then the corresponding data will be 1, 2, 3, 4, 5. This is maximum. This will be minimum. That's the range we have. Okay. Then I see a 5, so this one true. I see a 1, so this one true. I see a 2, this one true. I see a 4, so this one true. I see a 5, this one true. I see a 1, this one true. Okay, so this one true only. Wait, I'm sorry. I make another mistake. Okay, so here actually we don't have 3, right? I'm sorry. Let's redo it again. I keep doing the wrong way. Okay, so I see a 5, so this one true. Okay, I see a 1. 1 actually is index 0. Okay, I see a 2, so 2 here. Okay, I see a 4 here. I see a 5 here. I see a 1 here. So here, so this index 2 location, data 3 is missing. Okay, and then I count the number of the availability. So C right now will be equals 4. So I create a new array of 4 data. I call it D. So 0, 1, 2, 3. Okay. Then I check the data. If this one's true, I put a 1 over there. It's a minimum plus I. I see this one to true, so I put a minimum plus I. It actually is minimum is 1. 1 plus I. So this one's 2. So I see a true over here. Minimum is 1 plus I. It actually is 4. Minimum plus I is 5. So that's the array I want to have. Is that okay? No sorting. No sorting. If you check the array, it's an order of n time. We do not have sorting. We do not go into the order of n square or n log n algorithm. This one is pretty fast. Trade-off is that you need to waste the memory. So if your memory is enough and your data that is not really spread out in a wide range, this one is a good solution. Any question? And Natasha, can you understand it?
Yeah, I understand.
Okay, make sure, okay? Make sure this one. So this is one way we can write it. Is there any other way to write it? Yes, there are other way to write it, okay? So let's actually have public, okay? Packing number 2, okay? Packing number 2, so static, okay? Here let's return integer array, okay? So this one packing number 2, okay? Pack 2, okay? So let's call pack 2. Pack 2, we see the same array, okay? So now this pack 2, I'm going to print the same thing, okay? Except that the function code right now, I'm going to call pack 2 function, okay? I'm going to write the pack 2 function. So I have a data that is, okay? I'm going to use something called array list. So I create array list of integer. called a list, okay, equals new array list. Okay, so I'm going to do this one, okay, and this one is packing, okay. So packing, so here, okay, for integer I equals 0, okay, let's actually get the integer x, okay, integer x, and then let's see here, okay, let's see, from A, okay, we get every data from A array, okay, get every data from A array, and then we would try to go through the A list, okay, go through the A list. So integer, let's actually do P equals 0, okay, so P equals 0. So actually, while, okay, P less than A list the size. So I check every single one, okay, and also X less than, okay, X actually will be less than the what? Less than this one actually it will be less than this one actually it will be less than equal, okay, equal you will also bypass it, okay, equal you will bypass it, okay, equal you bypass it. So basically this one while it's less than or equal to your data, okay, so this one it actually is a list that get P, okay, get P. So you try to get every possible data, okay, so get P less than the size, and this one, okay, you less than equals to get P. Actually, I'm sorry, this one should be greater equal to, okay, get P, you will continue to move, okay. Actually, let me see, actually it should be greater than, okay, greater than this one, okay, greater than. So here, if actually X is equal to A list that get P, okay, so you actually go through it, you have the same value as the current P's location, okay. So this one you will break, okay, you will break, okay, you break, okay, you break. You will break is a while loop, okay. You break this while loop because if you equal to some data, okay, you will just break it. You just break it. So here let's use a Boolean variable. So this one let's actually use a font, okay. Font equals false. So here I would say font equals true, okay, equals true, and then here I would actually do break, okay. I do actually, okay, I'm sorry, this one font equal true is okay. Okay, if it's equal, I do font, okay, I'll do font equal true, okay. And then here I will do break, I will break out the loop, okay. And here my P will increase, okay. My P will increase. So so I get out, it's possible that I equal some value in the list. So my font will be true, okay. So right here, okay, my font equals true, okay. So if actually font, okay, if font, then we will do actually continue, okay, continue, okay. Otherwise, we come over, okay, so that data should be something I would like to add to the location, okay. It will be the data I would like to add to the location. So when I break it, okay, I break it here, I continue to export data until the data is actually, I will see a data, and that data actually you have, say you have 5 and you are smaller than that, okay, you will actually be less than equal to, then here it be greater than the value, okay. So equal, you do this one, okay. When you break, it will be less than, okay, less than. So here this one is actually greater or equal, okay, or equal, you will actually continue, okay. So if that one, you should add the data to it. So you add this, that add, okay, you add the data P with the data of the X, okay, and you will add your data into your list, okay. So let's look at it one more time, okay. So you create an array list, and then every time you get the data, right, you start to search it through your array list one by one, okay, one by one. So if the P less than the A list size, you will continue to do that. If it's greater than that, you will get out. Get out, you will actually add the data to the location P, okay. So you will continue to go through each data, and you will stop only when X is less than a certain value, okay, a certain value. So if it's equal, okay, if it's equal, then you will you do it. So let's do this, okay, let's multiply it a little bit, okay, multiply it a little bit. So this one, let's actually do greater, okay, and let's put this one, okay, let's put this one, cut this one, okay, cut this one. So when it is equal, when it actually equal, less than or equal, you get out, okay, so equal, you break, okay. So right here, let's actually put it over here, okay. So this one, let's actually do continue here, okay. Then I don't need this one. Let me delete this one. Okay, let's look at it one more time, okay. So here you get an array. You have 5, 5, 1, 4, 2, 3, okay. So right here, that's my array, okay, my array. I get 5, okay, I get 5, and then I check my 80 right now is empty, okay, empty. So because it's empty, so P stay at 0. P stay at 0, okay. Here you also check P should less than A list, the size, okay. In that case, you will do this, okay. You do this. If it's actually equals to the size, you will directly add the data in, okay. If actually it's less than the size, and then the X value is equals the get P locations value, okay, then you will continue, you'll break this iteration and then try next number, okay. So you see the second file, you will continue, you will break it, okay, and then basically go through it one by one. So you would pick up the non-recurring one, okay. So this one we finish, and after that we need to convert the array list back to array, okay. So for each integer, okay, X from A list, okay, and here I should have another pointer integer P equals 0, okay, and I would have my, so I create another one. Here we should have integer array, okay, B will be equals new integer, okay. This one will be A list size, okay. Use A list size to create a new list. So your B's P plus plus will be equals your X value, okay. At the very end, you return your B value, okay. That's it. This one will perform the same packet, okay. Let me show you one more time how this one works. This one actually is using array list, okay, using array list. So you have data 5, 5, 1, 4, 2, 3, okay. So you see the first 5, okay, the X is 5. Now your array list, A list right now is empty. You are empty, so you don't go into the loop. You don't go into here, you directly add the 0 with the 5. So 5 being added to here, okay? 5 being added to. You look at the second 5, okay? Go back, you look at second 5. You look at the second 5. So this is found equals false. This one not needed, okay? Not needed. So you go to there, you actually looking for the array list until this one greater or equal to u. So actually this one equal to u. This one equal to u, so I'm going to bypass the second one. So this one got bypassed. Okay. Then I see a one, and then I go to here, and then you keep increasing until there's one that actually is bigger than me in 80. Yes, 5 bigger than me. So I'm going to put my 1 over here. And then I see a 4, and then 4 put in here. Okay, so something like that. Keep doing that. You should solve the problem. Okay, you should solve the problem. Okay. So this one's picking number 2. So let's try different array. Okay, this A probably this A probably 2 is 1 to 10. Okay, so let's try different one. Let's try B. Okay, so B does it have 23, 44. Okay, 1 and then 2 and then 66 and then 8. Okay, so let's try such an array with B. Okay, with B, and then that's actually 2 picking number 1 and 2 picking number 2. Okay. Well packed. Okay, both well packed. Any question? So these two totally using different algorithm. Okay, the second algorithm is you insert the data only when there is no repeat, and you insert this one is to find the 1, 2, 3, 4, 5, 6, 7, and then if there's a 10, your 9 will be stopped over there. Is that okay? You try to find the insert location for the data. The inner loops function is to find the insert location. Okay, find the right insert location. So if it equals to the some value, that means that it's a duplication. Duplication, then I don't add the data into the list. If no duplication, I add it to the list. Okay. And then after that, I have array list. So I create a new array and then copy my data from my array list back to array, and I'll pack it. Okay, so right here, this is second algorithm, also no sorting. Only use array list to do packing. Is that okay? Hello? Any question? So I give you 2 versions, okay? Give you 2 versions to write this same algorithm. Is this too hard? No, I don't think so. This should be within the range that AP may test, okay? I don't see this one is too hard. This one should be reasonable difficulty, okay? So this one called picking. Let me pause the picking algorithm. Any question? Hello, any question? So Amy, are you okay?
Yeah.
So why I don't review the problem by taking the sum for array and then taking the maximum and minimum for array? Why I don't review those kind of problems? Because those problems are too easy. You guys should be able to handle it, okay? So I try to find some of the algorithm, maybe a little bit not too hard within AP, but the harder side of the problem. We try to review those portions. We don't try to review the easy part of the AP problem set. Is that okay? Does that make sense? Any questions so far? Any questions so far? Okay, so here we also review, in fact, we also review how to find a minimum and maximum. Okay, we also use that. So I'm showing you that how to use array and array list to solve this packing problem. Okay, to solve this packing problem. No sorting use, no calling sorting algorithm. Okay, completely no sorting algorithm, only array and array list. Okay. Any questions so far? So what I want you to do is after class, please, I send all the file in the chat box. Please download them, okay? Download them and starting from easy one, rewrite it by yourself, making sure that you understand everything, okay? Amy, is okay?
Yeah.
How about Natasha, are you okay? Hi, Natasha, is okay?
Yeah.
If you have question, what should you do?
Ask.
Yeah, ask, okay? Just simply ask, okay? Don't hide it, okay? So you can email me my email again. I give you my email, okay? echow510@gmail.com, okay? Email me that I need help on certain problem, okay? I'll answer you. I'll try to find time to Zoom you if possible, okay? Try to find time to Zoom you, or next week I answer you, but because we are too close to the exam, so next week could be too late. Okay, so it better you just email me and I try to Zoom you. Usually it will be in the late in the evening, maybe 10 o'clock, 11 o'clock, but I'll try to Zoom you. Is that okay? Any question in general for AP ComSci A so far? So we review quite a few problems today, okay? Most of them are on the harder side of the AP problem. It's not out of bound, but will not be the easy one, okay? And the easy one, the Friday maximum minimum, please download these slices and study it, okay? We do have Friday minimum, Friday maximum, copy 1D array to 2D array, those kind of simple one, okay? I don't repeat that because I believe most of you should be able to handle it, okay? Any question? Any question? Okay, no question. We're up to here today. Is okay? Good night then. Good night. Good night. Bye-bye.
Thank you.
Thank you. Bye-bye.